Hello, my name is Drake Geno, and today I'll present my reproduction of the deep residual network paper by Hay et al., focusing on their core finding that skip connections solve the degradation problem in deep neural networks. This is a track 1 tiny reproductions project for ECE57000. Before ResNet's researchers discovered a puzzling phenomenon that adding more layers to a network sometimes made it worse, not better. This wasn't overfitting. Deep networks just had higher training error than shallow ones. This is the degradation problem, and it suggests that very deep networks are fundamentally harder to optimize. The ResNet paper proposed an elegant solution: skip connections. Instead of learning a direct mapping for the function, residual blocks learn the difference for that function, x here. With skip connection, that adds the input back. This simple change allows the gradients to flow directly through the network during backpropagation, making optimization much easier. To reproduce this finding efficiently, I simplified the experimental setup. Instead of ImageNet with 50 plus layer networks, I used a ECE57000 with 20 layer networks. I implemented two models, Plane 20 and ResNet 20. They're identical, same 20 convolutional layers, same 272,000 parameters, except ResNet 20 includes skip connections, while the Plane 20 does not. I followed the original paper's training protocol, SGD optimizer with momentum, initial learning rate of 0.1 that drops by 10 times at epochs 80, 120, and 160. I trained for 200 epochs total with a batch size of 128. Data augmentation included random crops and horizontal flips. Both models trained for about 2 to 3 hours each on the GPU. Now for the key results. This plot shows training and validation error over 200 epochs. Notice three critical findings here. First, ResNet 20 achieves lower training error, about 0.6%, versus the 1.1% for the Plane 20. This confirms the degradation problem. The Plane network is harder to optimize even on the training data. Second, the gap persists on validation. It's about 8.3% for the ResNet versus the 9.3% for Plane. This isn't overfitting. This is the optimization phenomenon. Third, you can see the learning rate drops at epochs 80, 120, and 160, causing these sharp improvements for both models. But the ResNet maintains its advantage throughout. Let me highlight the final numbers here. Plane 20 achieved 9.29% best validation error, while the ResNet 20 achieved 8.32%. That's a 0.9% absolute improvement, or about a 10% relative error reduction. This cleanly demonstrates that skip connections enable better optimization in deep networks. Why does this matter? The insight that skip connections solve the degradation problem was transformative. It enabled training of networks with 100, even 1,000 plus layers. This finding influenced virtually every modern architecture. DenseNet, ResNext, EfficientNet, and even transformers use this skip connections. My reproduction on ECE57000 validates this insight, holds across different scales and data sets. All code is fully reproducible. I implemented the models in PyTorch from scratch with complete training and visualization scripts. The entire experiment runs in about 6 hours on a single GPU. The README includes detailed instructions, and I've provided all training models and results. I've also included a quick demo video with the package, assuming it will let me submit it, that can be used as well, and a requirements.txt file for all necessary Python packages. In summary, I've successfully reproduced the core finding of ResNet's paper. Skip connections aren't just an architectural detail, they fundamentally solve the degradation problem, enabling effective training of deep networks. Thank you.